So our second little lesson for tonight, and this is the final lesson. This we have now covered everything in all of the review units. So for Math 052, 053, this is section 2.5, the final thing. And for Math 038, I think we've also done it. Well, maybe we might have missed the estimating one, which I can throw in later. Really, if you're an O2 level course and watching this, there's not really any direct connections to your courses now, other than sometimes it's nice to sort of get a sneak preview of what you're going to be doing in a later course, because you're all heading to the O5 courses, I assume. So we got these three words in this section: commutative, associative, and distributive. And you do need to know what these mean, at least for this one section in the course. They're going to ask you to, they're going to give you examples of things and ask you which of these three it demonstrates, or they might give you, they might set up a little expression for you and ask you to write something that demonstrates the commutative property or the associative property or the distributive property. So that is, I just got a ding on an email. I'm just going to check in case it's someone trying to get into the room. No, I think we're good. Okay. All right. So let's go through these, and you want to try and come up with, they're not very nice words, but if you can come up with ways that make sense for you to remember what each of them means, that will help you out. So commutative property first. It applies only to addition and multiplication. It is not true for the other operations, subtraction and division, but it is true for addition and multiplication. And commutative property simply refers to the fact that the order doesn't matter when you're adding or subtracting. So 5 plus 3 is 8. 3 plus 5 is also 8. They're the same. That is the commutative property. That's all it means, that the order you add things in doesn't matter, or the order you multiply things in doesn't matter. 4 times 6 and 6 times 4 are both equal to 24. And we want to notice, as we said, it's not true for subtraction or division. So there we have 7 minus 5 and 5 minus 7. They are not the same. 7 minus 5 is positive 2. 5 minus 7 is negative 2. Not true. 15 divided by 3 is 5. And 3 divided by 15, well, that's a fraction, 3/15, 1/5. So commutative property, true for addition, true for multiplication, not true for subtraction, not true for division. The associative property. So the associative property is also true only for addition and multiplication, not for subtraction or division. And what the associative property says is that if you have three things or more, actually, three or more things that are added, then the order that you do the additions in doesn't matter. This is not saying the same thing as the last one. In the last one, I switched the order of the two things, 5 plus 3 and 3 plus 5. That's the commutative property. The associative property says which additions you do first and which additions you do second doesn't matter. So there I have 3 plus 5 plus 10. If I want to, I can go 3 plus 5 is 8, and then add 10 and get 18. Or if I want to, I can add the 5 plus 10 first. 3 plus 15 also equal to 18. That's the associative property. Which additions I do choose to do first doesn't matter when I have a whole bunch of additions. If I have other things in there, forget it, you got to go to order of operations. But if I have a whole bunch of additions, I can choose which ones feel the easiest to do first. And the same with multiplication. 2 times 3 times 5, I can go 2 times 3 is 6, and then multiply by 5 to get 30. Or I can do the 3 times 5 first because it's all multiplication and get 15. And you see I get the same answer. So only true for addition and multiplication. If you have a bunch of adding or a bunch of multiplying, you can pick which ones you do first. And again, we want to notice this does not work for subtraction or division. So here's an example with subtraction: 20 minus 10 minus 6. You can't say, sorry, here's the correct way to do it. 20 minus 10 is 10, minus 6 is 4. You cannot say, oh, hey, I'm going to do the 10 minus 6 first and get 4. Incorrect, like that. So does associative property not true for subtraction? Now, if I rewrote this as all addition, so 20 plus negative 10 plus negative 6, then I could use the associative property and you would discover that it does work, but it's only as long, it has to be addition, not subtraction. Also important, the associative property isn't true for combinations. So that's, remember, you have to use bed mass if you have combinations of operations. Remember that division and multiplication are actually the same step, and you have to go left to right. And addition or subtraction happen in the same step, and you have to go left to right. So if we have 20 divided by 5 times 2, you have to go left. Division and multiplication are tied. They go at the same time. You have to go left to right. You have to do the 20 divided by 5 first, is 4, then times 2 and get 8. You cannot go 5 times 2 first and get 10 with an answer of 2, which is incorrect. So the associative property, one more time, the which ones you choose to do first doesn't matter if you have a whole bunch of addition or a whole bunch of multiplication. Any other situation, any other operations, any combinations of operations, out the window, you got to use bed mass. Lastly, the distributive property you've seen demonstrated a whole bunch of times this evening with the questions that we've had from equation solving. So it's a combination of multiplication and addition, and the distributive property says that if you are multiplying by a bracket with separate terms being added or subtracted, then you can multiply each thing separately. So there's an example. I have, here's, see what I mean that I'm combining multiplication with addition or subtraction. I have 3 times, right? We don't bother to write it, but we know there's a times sign right there. And then in the bracket, I have 2 things being added. I can do this with good old order of operations, which, by the way, is how I would do this particular question. But as soon as we toss variables in there, you won't be able to do that. So I go 2 plus 5, and I get 21. Or I could use the distributive property, and I could say 3 times 2 plus 5 is the same as 3 times 2 plus 3 times 5. Let's try it out. 3 times 2 is 6. 3 times 5 is 15. Sure enough, we get the same answer, 21. So this is probably the easiest one to remember, because remember the phrase multiplication distributes over a bracket. It distributes into both of those two. So I think, so we often think of distributive property as the number out front is being multiplied through the bracket. That's the phrase you'll hear math teachers say all the time. So there we have 5 times x minus 3. And you notice in this case, I can't do order of operations. I can't go x minus 3 because I don't know what x is. So, so you see I've made that minus sign red. That minus sign is going to stay a minus sign. And that 5 is going to multiply by each of the 2 things in the bracket. That's the easiest way to distribute a bracket. You can think about the 3 as a negative 3, but that generally leads to more problems than it helps. So think of it as, hey, there's a minus sign. Okay, it's going to stay there. And then I'm going to multiply by 5 by each of the 2 things, 5 times x and 5 times 3, like so. 5 times x is just 5x. 5 times 3 is 15. And here I'm going to go, Sasha asked earlier what when it asked you to simplify what it meant. This is a classic simplify question, and this is a classic one where people go too far. This is as simple as this gets, 5x minus 15, but people will try to combine it. They'll try to subtract the 5 and the 15 and get negative 10 or something. You cannot, these are not like terms, right? This is as far as you can go on that. That is the answer. So again, notice how the 5 distributed through the bracket, the negative sign stayed the negative sign, and we ended up with things on either side of it. If this 15 had turned out to be negative 15 for some reason, then the minus and negative would have turned into a plus, right? But yeah. So here we go, same thing again. This time it's a plus sign in between, so that plus sign is going to stay there. And I'm going to distribute the 2. Oh, I didn't do my little curly things this time. 2 times m and 2 times 8. We can draw those in. Let's draw them in while we're here. Right, so we went 2 times m and 2 times 8, like so. Excuse me. 2 times m is just 2m. 2 times 8 is 16. Don't try to go 2 plus 16. Those are not like terms. They cannot combine. 2m plus 16. So that is the distributive property, most often appearing with something in front of a bracket, although there could be other ways you could demonstrate the distributive property. So here's a summary, a good screenshot screen, and you know what, I'm going to screenshot that. And if any of you can't do a screenshot and want an email of that, let me know. So we are going to take, you know what, let's take 5 minutes. And you guys take a look at these, and I would like you to put by every single one of those either a C, an A, or a D if it demonstrates the commutative, associative, or distributive property, or put an X if the statement is actually not true. And I give you a little hint there. There's 2 of each letter, and then also 1 of each type, so 3 in total that are actually not true. While you do that, I'm going to take another email ding I'm going to check. Okay, let's take a look at these. So the first one, well, first thing I notice is I got a whole bunch of addition. And if I look at the left side, it says to add the 20 plus the x first and then add the y. But the right side, because of the bracket, says to add the x plus the y first and then add the 20. So this is the associative property. You have a whole bunch of addition, and you are showing that which ones you choose to add first don't actually matter. Over to B, t minus 5 equals 5 minus t. Well, we've switched the order of the t and the 5, so that's kind of like the commutative property, but we know the commutative property only works for adding and multiplying. We can even check this out if you want. Choose a number, like imagine that t is 10. Is 10 minus 5 the same as 5 minus 10? No, because one's positive and one's negative. This one is not true. The commutative property does not work for subtraction, only for addition and multiplication. Third one, okay, well this one's probably maybe the easiest one of all. Just check that they didn't make the numbers wrong, but that 15 can multiply through the a plus 10, giving you 15a plus 15 times 10. That is the distributive property. And the plus in the middle stayed the same. xy equals yx. Okay, so we've just reversed the order. We've said that if you multiply 2 things, the order of them doesn't matter. That is the commutative property. True this time, because it does work for multiplication. 5 times 2 is the same as 2 times 5, for example. Part E, again, we have 3 things. Now, this first one, I didn't throw the extra bracket in, but we know that if there's not a bracket there, we would go A times B and then multiply by C, right? This says that we would get the same answer if we went B times C first and then multiplied by A. That is true. That is the associative property. A whole bunch of things being multiplied. Which ones you multiply first don't matter. As opposed to commutative property, 2 things being multiplied, you can reverse the order. Notice here we haven't reversed the order of anything, right, in the associative property. It's still ABC. Over here, 3 times 10 equals 3 times 8 plus 3 times 2. Now, this is my trick one, because that doesn't really look exactly, it's certainly not the commutative or associative property. It doesn't look like the distributive property because there's no brackets. So check it out and see if it's false. 3 times 10 is 30. Well, I think I do this, actually. Is it true? Yes. Is it true? Because if it's not true, then it gets an X. 3 times 10 is 30. 3 times 8 is 24, and 3 times 2 is 6. Oh, it is true, right? 30 equals 24 plus 6. Okay, so both sides are the same, so it is true. So what I did here is I did a little sneaky thing, because 10 is equal to 8 plus 2, right? So really, I can think of that 10 as being an 8 plus 2 in a bracket. And then right away, when you think of it that way, you see that this demonstrates the distributive property. 3 times 8 plus 2 is the same as 3 times 8 plus 3 times 2. That's about as sneaky as these get. 60 divided by 10 times 2 is the same as 60 divided by 10 times 2. Well, that looks like the associative property, but we know the associative property only works if you have a whole bunch of addition or a whole bunch of multiplication. That is not true. Here we go. Well, this one, I think we can see the distributive property happening there. The minus sign stayed the minus sign, and we went C times 7 and C times 2. Oops. Oh, I got to give away the next one. We've already given away the answer. This is an X. So 20 divided by, oh yes, okay. So, sorry. It looks like the distributive property, that 20 is distributing over the m and the n, but it's division. Distributive property only works for multiplication by a bracket, not for division of a bracket. You can't spread that 20 into the bracket and divide both of the different things. That does not work. It will not be true. All right, so that is that. And let's see, using this, yeah, okay, so final thing we're going to do is we're going to look a little bit more at expanding brackets, which, as you've been seeing from the questions during the open question time today, comes up an awful lot in all of your math courses going forward. So we have 2 brackets to expand and then collect in both these examples. First thing I want to do is, notice I threw a plus in front of the 3. So there's the question. Never forget that when we don't bother to write a sign, there is a plus in front of it. And I put one of them in red and one of them in blue, because the plus 3 is going to multiply through, sorry, I'm just having a little trouble with coughing here. Happens to me sometimes when I talk a lot. The positive 3 is going to multiply through the first bracket, and the positive 5 is going to multiply through the second bracket, and then we're going to try and collect everything up. So 3 times x plus 6. Oh, what happened with the colors there? Sometimes PowerPoint, when I change colors in later slides, makes weird changes to earlier slides. I don't know why it does it. So there in red, we see the 3 went through the first bracket, 3 times x and 3 times 2, with the plus sign in the middle right there. And in the second bracket, the minus sign in the middle right there. And the 5 went through plus 5x and minus 15. Positive 5 times negative 3, negative 15. And then I'm going to erase those colors, because now I'm going to rearrange this in a different way. I want to collect like terms, so I'm going to take, yes, I'm going to rearrange now with the associative property. So I'm going to take all of the x's and put them together, and all of the ones that don't have a variable and put them together. Those are called the constants. The 6 and the negative 15 called constants. And now I can combine 3x plus 5x is 8x. Positive 6 and negative 15, so that's 6 to the right and 15 to the left, or as we were discussing earlier, think of this as they are going in opposite directions. Therefore, You subtract them. 15 minus 6 is 9. Which one is stronger? Which one went further? I went further to the left than I went to the right. Therefore, my answer is going to the left, negative 9. Don't try to combine those together. They cannot be combined. That is your final answer. Let's look at the other one. So same deal. I'm going to go negative 6 times the first bracket. Right. Look at this second bracket. There is nothing in front of it. Does anyone want to be brave and tell me what is actually there? No. Last time, Murr referred to it as a sneaky little 1, which I liked a lot. There is a 1 in front of that bracket, and it'll help you to remember that, to stick that 1 there. So it is minus 1 in front of the second bracket. Negative 6 in front of the first bracket, negative 1 in front of the second bracket. Let's expand them now, like so. So negative 6, and it did that weird thing again. Let's fix that color. There we go. Negative 6t plus 6. So negative 6 times t is negative 6t. Negative 6 times negative 1 is plus 6. Don't just say 6, right? Because then you lose the fact that that 6 is being added. So a lot of people will do that. I'll say, what's negative 6 times negative 1? They'll say 6. And they just write a 6 down. But it is a plus 6. Every piece needs a sign in front of it. Over here, the negative 1 times t is negative 1t. Negative 1 times 4 is plus 4. So there's my bracket expansion. You see how I needed to remember there is actually a 1 there. Now we are going to recolor, because I'm going to now group together the pieces with a t and the pieces without a t so that I can collect like terms. Negative 6t minus 1t, those are both going to the left, so we add those together to get negative 7t. 6 plus 4 going to the right, add them together to get plus 10. And there is that bracket expanded. Negative 7t plus 10, you can't go any further. That is the answer. All right, last little topic. We're getting close to done here. Your test is going, your chapter 2 test, for those of you who are doing the review unit, is going to, you're going to run into a question that says, what is the multiplicative inverse of this number? And if you don't know what the multiplicative inverse is, that is going to be a tough question to do, or the additive inverse. So very quickly, we're working here on the property that we know that adding 0 doesn't change a number and multiplying by 1 doesn't change a number. Those are important properties in math, because I'd say 3/4 of math is adding 0 or multiplying by 1. I'm talking about like 5th year calculus at university. But you're adding 0 and multiplying by 1 in very special ways that change the equation in a way that you want to. So, yeah, we very often use these relationships to help us solve questions. That's exactly what we're doing when we're moving the pieces around solving an equation. When, technically speaking, we're adding 0 and multiplying by 1. Okay, so the number that makes something add up to 0 is called its additive inverse, and the number that makes something multiply to 1 is called its multiplicative inverse. Additive inverse is pretty easy. It's just the negative, right? What do you add to 8 to get 0? You add negative 8. So negative 8 is the additive inverse of 8, and vice versa, 8 is the additive inverse of negative 8. Why? Because you add them together and you get 0. Multiplicative inverse, we notice that 2/3 times 3/2, let's just look at this, is 6/6. What is 6/6? 1. And we realize that would be true no matter what those fractions were, right? If this was 5/17 times 17/5, you'd get the exact same thing on the top and bottom, which is the number 1. So the multiplicative inverse of a number is its reciprocal. 2/3 is the, I'm getting tired of saying multiplicative inverse, but that's what I have to say. 2/3 is the multiplicative inverse of 3/2 and vice versa. So, in summary, The additive inverse of a number is just its opposite. So when they ask you the complicated sounding question, what is the additive inverse of 34? You know it's just negative 34. In fact, all the way down, we're just going to do the left side in one shot here. It's just the opposite sign. The additive inverse of negative 152 is positive 152. Doesn't matter if it's a fraction. The additive inverse of 3/4 is negative 3/4. Doesn't matter if it's a decimal. Doesn't matter if it's a mixed number. The additive inverse is just the same thing with the opposite sign. If I wanted to get maybe a little technical here, I might toss a plus sign in front of those two, like that. I don't have to, though, because we know if there's a plus in front, it's not necessary to write. All right, over to the right. So the multiplicative inverse is the reciprocal. This gets a little trickier because not all things come to us as fractions. 3/7, well, that's easy. The multiplicative inverse of 3/7 is 7/3. You just flip it. Doesn't matter if there's a negative sign out front. The negative sign stays there. If you don't believe me, try it out. These two multiplied together should give you 1. A negative times a negative is a positive. Good so far. 2 times 5 on the top is 10. 5 times 2 on the bottom is 10. Sure enough, multiply those two things together and you get the number 1. So notice that a multiplicative inverse that's negative stays negative. Now here we have a problem because this number is not a fraction, but we know it is because we know negative 7 is the same as negative 7/1. And so we flip the fraction, leave the sign the same. The multiplicative inverse of negative 7 is negative 1/7. If you multiply them together, you will get 1, positive 1. 0.9, again, doesn't look like a fraction, but sure, we know it is. 0.9 is 9/10. So the reciprocal is 10/9. And lastly, this is a mixed number. That's not going to work. We can't do the reciprocal of a mixed number, so we turn it into an improper fraction. 2 times 3 is 6, plus 1 is 7. So 7/3. And the multiplicative inverse, therefore, is 3/7. And I think that is it. Yes, it is. Okay, so a whole bunch of words today, right? Associative property, distributive property, commutative property, additive inverse, multiplicative inverse. Those are things they are going to ask you about on your Chapter 2 test.